Today we're going to look at an issue that I inadvertently found while I was looking at some of this stuff for another video, and that is when we last left, if you remember, we had this collision here working with the axis-aligned bounding boxes, and in the previous episode we had these circles that we had colliding correctly. But if you try it out, I'm sure you may have already done this if you've been following along. I can push them inside, and of course they come back out. So obviously there's an issue here that we have, or that I have overlooked, and I'll show you where that is. And it really turns out to be somewhat of a mistake in how the Vector2 module was implemented. Now, first of all, let's go to the utils directory. This is going to be where the issue is. So I'm going to go back to test, which is where this little scene comes from, if you remember. So haven't been doing a very good job of doing comments, have I? So let's say right here is where we check if the circles collide. And you can see we're just saying, hey, if they collide, then set the color to, for that C1, set it to a different color. Otherwise, just set it to standard white. And if we go down here to utils and we look at colors, or the circle collide, which is here, this says we said this collides a circle, two circles together, and if they overlap, it applies a separation vector basically to one or both of the circles. And the ratio was the amount that it affects each circle. So if it's 1, then it affects circle 1 all the way, and then circle 2 is not moved at all. Half would be that separation vector is applied. Half of it is applied to each of them, so they're moved out, both of them. Anyway, and that could actually be used to take a ratio of, say, the masses of each of the circles, and then you could have one move more than the other if it was more massive or whatever. So, but what we want to do is, and by the way, that word, that is not correct. It's not really a unit vector because we're multiplying it right there, and that ends up actually being the issue. But if you look, you see where I'm multiplying this unit vector that I'm getting here. Then I'm doing a multiplication of it. Well, what I've assumed, and I've assumed that incorrectly, which is funny because I'm the one that designed this Vector2 module, that the multiply affects this particular instance of that module. So the vector, we'll call it a class, the vector class, that it affects it what they call in place, and it doesn't. So if you look here, see what we're doing here. So we calculate the magnitude of a vector. We've got all these different operations. We are not affecting the actual instance of that object in place. Instead, we're returning a brand well, actually that one is just the magnitude, so really that's fine. That's just returning the magnitude. But when we add, we subtract, we multiply and divide, if you notice, we're returning a new vector. And that's okay for the add and subtract, because if you look at how they're being done, that we're using the dot notation, so there's no implicit this. That's what you want for this, right? For this kind of thing. So, but with the multiply and divide, we're doing the colon, which means implicit this, which means we can do what we did over here in test. No, I'm sorry, over here in the utils, which is we make a vector, and then we make it a unit vector, that's C1 to C2. So we grab the magnitude of this. No, I'm sorry. We made a vector here, and then we took the unit. We got a unit vector of that. And then we say, okay, take that unit vector and multiply it by this quantity here. And what that should do, and if you look at any other implementations of libraries and other languages, what that should really do is modify this instance in place. And then what I mean by in place is we don't want to return a new vector like this. Instead, what we would want to do is we would want to say self.x equals self.x times value. So we're modifying that, what you call in place. So that makes more sense because we're calling a multiply function. We're calling that multiply method on this thing. So it really should modify that in place. And the only time when you see that that's not the case usually is when you have, in other languages like C#, when you have something like a static method, and then you have the two objects you want to operate on, which is kind of what we're doing up here. We're using the dot notation, and then you have to explicitly pass each one. Then we're returning a new vector. That makes much more sense. So what we're going to do is we're going to go through this, and we'll modify, at least multiply. Let's start with multiply. We've modified so that it modifies the values in place, which is what we really want, and was the source of the bug. But what we want to do also is check, and I want to see where else we call this. We may only call it that one place. If that's the case, then we're good. Yeah, it's just right here. Or I'm sorry, right here. So we're just saying, okay, so now we're saying unit that multiply that object by this quantity and modify it in place. So that way we're not creating a new vector. And then if we run this now, and we'll make sure that this still works, which it does, but now you'll see the circle stuff still works because we're actually doing that correctly. Now, so with this in mind, since we did this, we really should do the same thing. You know, a lot of this programming stuff is about consistency. You want to be consistent so you know how things behave, right? So we probably want to do this also, and basically have this modify that vector in place, since we're using the colon and we have that implicit object that's passed as the first parameter. Hopefully that is not too confusing. But let's look and see where we use div, because that's going to change things drastically since we're not returning. And we're using it in one place. So now this is modifying that in place. But if you look down here, we also still use new size x and y down here. So that means we're going to have to change this somewhat. So what is the best way to do that? What we could do, let me check. Let's say that, I'm not sure if I can do this. Yeah, it should be. Well, let's see. Can I name? I'm going to use a dot, and I'm saying, can I have two of the same name? See, I've got a div and a div, but one's a colon and one is a dot. Can I do that? V1. So in other words, if I want it to return a new vector, then I explicitly pass it in. Otherwise, let me try this real quick. I'm just going to return just an empty vector. So I'm going to see if this even runs. Yeah, it looks like it's okay. There you go. Attempt to index local v2 a nil value. So, and where is that? That's in Minowski. That's in rect 51, which is right here. Yeah. Okay. Yeah. Well, let's do this. Let's try this. So let's see if I can use my new dot div, and then that would be, and actually it would be this, and it's not going to be. So that should be a new vector, and then this would be divisor, right? Is it the divisor or the dividend? I don't even remember. Divisor. I'm going to look it up real quick. Yeah, the divisor. The divisor is a number by which another number is to be divided, which is exactly what we want. So then we can return v1.x divided by divisor and v1.y divided by divisor. And we also want to do this. Assert that the divisor is not 0 because we don't want some weird crazy value. Let's see if this actually works. There. Okay. So where were we at? Oh, look, we're in function add. We're still in 51 though. Oh, it's Vector2. Lua 19. That's a Manowski difference. So let's go back here and look at 51. Yeah, okay. So they got a vector2.add, vector2.div. Is it actually getting in there and calling that? Would it even allow me to print this and see if not this one, it's this guy. Yeah, see, it says attempt to index a local v2 a nil value. So it must be calling this one. That's crummy. Let's do this. Let me just spell this one out. This is how we can verify that it is indeed doing that. It probably is. So if we do vector2.divide, that's sort of an explicit one, which returns a brand new vector. And that should work, and it does. So let's do that. It feels better that way to have, I mean, when you call a colon function or for an implicit this on an object, it really probably should modify that object in place. So we'll do a v.divide, and then we'll just do a v.multiply, and those will be the what you would call, quote, a non-object specific, or a sort of what you would refer to as a static method in other classes. So multiply, so then we would want to return this, which we would multiply, not self, but we're going to do v1 and v1 here. So hopefully that makes sense. So when we have to explicitly give it both parameters like this, then we will assume that it returns a new thing, a new object of that type. And when we don't, at least for the multiply and divide, it modifies it in place. Let's run that again. We'll check it real quick just to make sure that everything looks good. This is good. This is good. Nice. So now we're left with this guy. So calculates the unit vector of this vector. And we're returning a brand new vector there too. That makes sense to me. Yeah, I think we should leave this. These feel more correct this way because you're basically saying, hey, I want to multiply this by a value of some sort of constant. And it should modify that in place unless you explicitly call these the dot methods and also different name, of course. That's consistent with the add and subtract. This is fine because it doesn't modify, it doesn't return a new vector of any sort. It just gives you the magnitude of the vector. And look at that, I spelled magnitude wrong. I spelled it incorrectly. Now it's right. This one, you know, I think this is okay. I think this is okay. You know, if I was going to modify it in place, I might do a function called v_normalize or something like that. And then it would basically do this except for modify that in place. I don't think I don't think in this case we need to do that. Let's check and see where all this is used. Yeah, it's just this one place. And you can see that it's that's always one of the things that you have to look at whenever you're doing this kind of stuff is how should you modify the value or the object in place, or should you return a brand new object of that same kind? I'm just kind of looking at some of the other examples real quick. I was looking at actually looking at the Unity documentation just as a reference here. You can see here there's a normalize. It says makes this vector have a magnitude of 1. So it's sort of a, yeah, so this modifies it in place. See? This function will change the current vector. If you want to keep the current vector unchanged, use normalized variable. So they're doing it where the normalize modifies it in place. Let's change this. Ugh, I hate to change it really, but let's make another function down here, and then we'll just feed normalize and end, and then we'll just say grab the magnitude, and we'll modify everything in place like we should, I believe. That. Let's grab this, and we'll do it for y also. So this modifies the vector in, we'll just say in place to have a let's say modifies the vector in place to have a magnitude of 1, which is really what a unit vector is. Yes, indeed. So that normalize. So when you normalize it, that makes sense. We're only using it in one place, and it looks like when we use it, we're actually having to do that. See, we're C1 to C2 dot unit or colon unit, so we're grabbing that new vector and calling it unit, then we're multiplying it by this thing, in which case we could actually use the normalize function. Let's add another one called, because I can just foresee this happening, let's call it copy. And this creates a copy of the vector. Given, or the of this vector. Let's see, this Vector2 object. Since we are colon, then we would just return this.x y, or I'm sorry, this. I'm doing this and self and this. What's the difference? Well, there's a big difference. Okay, so now we can make a copy if we want to. So let's go and get rid of this. And maybe that'll return one day, but for now it's not going to. So that means all we need to do here is we just need to do that, say C1 to C2 or a normalize like this. And then we can say multiply that, and then we'll get what we want. So let's run this, and we'll see if our modifications are good. It's good here, and it's good here. So I think that feels cleaner to me, so that when we're doing functions which have that implicit this, and we're doing some sort of operation, it modifies those in place. We could, of course, also add, as I'm putting my cursor over add, we could also include these in this too, but I don't think that's necessary at this point. We may come back and revisit this later, but I think that solves our issue with that one little error that I found, and makes things, in my opinion, a little bit just cleaner. At least I feel like it's a little more consistent. So with that in mind, I hope this was helpful, and at least we fixed a few things going forward. So I'll see you in the next one next time.